Hey guys, Mr. Yisley here. So we're going to move on to the last section of notes, yay, of chapter 1. So this last section talks all about how to rewrite literal equations or formulas, which you should have defined in your vocab up above. So when it comes to rewriting literal equations and formulas, all they're really asking us to do is to solve for one of the variables, but rather than coming up with a number, you're going to have multiple variables involved. So you can't really solve for a specific number like we have. We're just going to rearrange the equations to solve for that specific variable. So with this process, how we do this is first we're going to identify the variable that needs to be solved for, and we're going to figure out what's being done to it. So it's really kind of just exactly like what we were doing. So we could create to-do-undo lists and solve using that. So instead of multiplying by 3 or dividing by 3, you might be multiplying by b. The process is still the same though. So we're going to identify the variable that needs to be solved for and figure out what's being done to it. Then we're going to reverse those operations by undoing it. So that's exactly what we've been doing, right? And then we're going to solve for the variable. And when we solve for the variable, the goal is to get the identified variable on one side of the equal sign and everything else on the other. So this process, to be honest, is really no different than what you've been doing. People just get a little bit confused at times because you're not always working with numbers, you're working with variables at time, more than one variable, but the process is the same. You're never going to end up with like x equals 4 on these. You're going to end up with things like x equals y over x, or x equals y over b, or things like that, depending on what the variables they give you. So we're going to walk through this slowly and show you. We've got 4 examples if you flip your notes over that we're going to go through. So let's take a look at the first one. So example A says 3y plus 4x equals 9. And they want us to solve for y. So I need to solve for y. So when I look at this equation, I see that my y is right here. And we've got to get the y by itself. It can't be 3y. It's got to be y by itself when we solve it. So when I look at this, I now need to identify, and if I create my to-do-undo list, this can help a lot, what I need to do. What's closest to y? What's farthest? How do I switch that from what's happening? So if I just went over here to my side over here, let me scoot this over, and create a to-do to undo list like we've been working on. You never thought you'd be so sick of hearing to-do undo, but it just seems to help keep us organized in what we need to do. So the first thing I see they did to y was they multiplied it by 3. The second thing I see that they did to y is they added 4x. All right, and this is what usually gets people. They're like, oh, well, they added 4 times x, and I've got to do all these. Nope, that 4x is all one term to us right now because we don't know what x equals. So really, they added 4x. So I'm going to crisscross this, just like before, and I'm going to do the opposite. So instead of adding 4x, I'm going to subtract 4x. And instead of multiplying by 3, I'm going to divide by 3. All right, so once I do that, I'm going to go in and I'm going to solve my equation for the letter y. So I'm going to rewrite it down here, 3y plus 4x equals 9. And the first thing I need to do is I need to split my equation, and I'm going to subtract 4x. Well, I don't have any x's on this side, so I'm just going to write it slightly to the right of the 9. So when I do that, that causes these to cancel. I'm left with just my 3y on the left side. And then I've got 9 minus 4x. Well, second step, I need to divide by 3 to get this y by itself. And divide by 3. Now, you could write it all as one like that. You could also write it with each one individually, and I'll show you what the difference is. So what I mean is I could write it as 9 divided by 3 minus 4x divided by 3. And I could write it that way, and that's just fine. And the reason we might want to write it this way is simply because sometimes we can simplify one of the terms but not both, so it makes a lot of sense to do it individually. All right, well, when I do this, I'm left with y equals, well, 9 divided by 3, I can do that. That's 3. Minus 4x divided by 3, I can't really do anything with that, so I'm just going to write that as it is, 4x divided by 3. So final answer here, y equals 3 minus 4/3 x, or 4x over 3 means the same thing. And I've got the y by itself, so that is correct. Now, would you be wrong if you wrote 9 minus 4x over 3? No, but you would miss out on a little bit of points, all right? About a half a point because you didn't get it in its simplest form. And we always, always, always want our answers to be in the simplest form possible. All right, well, here we go. Let's take a look at example B. X equals 3y plus 5yz. All right, and they want us to solve for y again. Well, when I look at this, I see that there's a y here and a y here. So a lot of people, what they think is, oh, I'm going to combine those because they're like terms. Well, remember, like terms have to have the exact same variables. All right, so if one of them has an extra variable, they're no longer like terms. Or if one they both have y's, but one's a y squared and one's just a plain y, they're not the same term. They have to be identical in terms of the variables. And these are not identical because this term has just y and this term has y and z. So what I have to do there in order to make this work is I'm going to actually have to do some reverse distribution, also known as factoring. And if you recall real hard from your pre-algebra or algebra prep class, you learned all about factoring. And that's where we look for something that's in common between both of these terms. And so I'm looking at these terms and I'm going, all right, x equals 3y plus 5yz. What is the same between 3y and 5yz? Well, the only thing they actually have in common is that they both have y's. Well, I'm going to go ahead and I'm going to factor that out. And I'm going to say, hey, y to the outside. Well, if I do that, now I'm going to have parentheses here, and this is all still equal to x. All right, and now I've got to go in and figure out, well, what did I multiply y by to get to 3y? Oh, that's just 3. And then what did I multiply 5yz by what did I multiply y by to get to 5yz? Well, if I took the y out here, that leaves me with 5z. So I had positive 5z. So this right here, y times 3 plus 5z, is the same as 3y plus 5yz. But what this allows us to do is isolate the y by itself. So now we're at the portion of, hey, my to-do, undo list. So I've got my to-do and my undo. So what are they doing to y? Well, the only thing that's happening to y is it's being multiplied by 3 plus 5z, because that's all in parentheses. Well, in order to undo multiplication, still the same, we're going to divide by everything in those parentheses, 3 plus 5z. All right, well, there's my step. So I'm going to split this in half, and I've got to divide both sides by 3 plus 5z. Divide by 3 plus 5z. Well, when I do that, that causes these to cancel on the right side, because if I've got the same on the top and bottom, I can cancel it. It leaves me only with y on the right side. And then the left side, I can't really divide 3 plus 5z into x, so it gets to stay exactly as it is. So y equals x over 3 plus 5z. So this one can be confusing, and you're going to see some of these on your assignment. The big thing you got to remember is the factoring portion. So you're going to have to really recall some of that previous information you've learned about factoring in prior classes. So looking for those common factors that they have. In this case, it's y. So we're looking to trying to get those apart. We can't really do anything here with that, so we just leave it as it is when we're rewriting these literal equations. All right, so example C. This is really no different. It's just a formula for area of a triangle. And so all we're looking at right here is we're saying, hey, what do we need to do to get h by itself? All right, what do I have to do to get h by itself? All right, well, first thing I notice is, hey, h is being multiplied by b and being multiplied by 1/2. All right, so when I do that, I'm going to write that over here. A equals 1/2 BH. Now this can look kind of confusing for people at times. So what I recommend, all right, when you get these and you're doing these formulas, when you've got these fractions out in front like that, is go ahead and move these letters up here to the top of the fraction. So we're going to write A equals 1 times BH all over 2. And all that simply does is that's going to give us a better frame of reference for what we need to do to solve. So when I look at this, I'm looking at h and I'm saying, all right, what's the closest thing to h? Well, that's 1b or just b, because really 1b is the same as just b, so I'm going to mark that out. So they, on my to-do undo, the first thing that they are doing to h is multiplying by b. The second thing that they are doing is then they are dividing it by 2. So they multiplied h by b, then they divided it by 2. Well, crisscross, do the opposite. So first thing I'm going to do is multiply by 2, then I'm going to divide by b. And there are my steps to solve. So first things first, I need to multiply both sides by 2. Multiplied by 2. Well, if you remember from our fractions portion, that means that I can get rid of these because they cancel out. So I'm left with 2 times a, or 2a, equals b times h. My second step is divide by b. So divide by b, divide by b. Those cancel, and I'm left with, I should draw my line to make it easier, h equals 2a divided by b, because there's nothing I can do to simplify 2a. I don't know what a is, I don't know what b is, so I'm just going to keep it as is. So h equals 2a over b. All right, well, example D, this one's really similar, to example B, so I would encourage you to use that as a template for yourself. Try example D on your own, and then check your answer with mine. All right, so first things first, what am I solving for? I see that I'm solving for L. All right, so I notice that L is right here. So I need to figure out what do I need to do in order to get L by itself. Well, other things that I notice here is both of these terms have pi, and this one has an r squared, and this one has a r by itself. So there are some common factors here, because remember that r squared is the same times r. So really what that means is pi times r, and that's going to be really helpful for us. So when I look at this, I'm going to rewrite it down here. S equals pi r squared plus pi r L. And I'm just going to make it a little loop. Well, it looks like a 2. That was terrible. We'll just make it a capital L for the moment, but it needs to stay lowercase. All right, so when I look at this, first thing I'm going to do is I'm going to factor out anything that's in common. Well, as we talked about, there's multiple r's here. There's pi's in both. So I'm going to factor out a pi and an r. Well, when I do that, I now need to have parentheses with a plus sign in between. So I'm saying, hey, what did I multiply pi r by to get pi r squared? Well, the only thing that isn't being used is the r. So I've got r here. And then the only thing not being used over here is the L. And I'm going to make it a cursive L. There we go. That looks a little bit more like an L. All right. And then I've got this S over here to this side. Well, once I've looked at that, I can now say, okay, well, what do I need to do to get the L by itself? All right. Well, if I create my to-do and undo, the first thing that I see they did is they added R to it. So they added R. All right, because it's inside the parentheses with the L, so that's why I know that's what they did first. Then the next thing they did is they multiplied it by pi r. So then I need to do the opposites, inverse operations. So the opposite of multiplying by pi r is divide by pi r, and the opposite of adding r is subtracting r. So now I've got my steps to solve. So first thing, divide by pi r. Let me split my equation. Divide by pi r. All right, well, when I do that, these cancel. I'm left with just r plus l, and I don't even need the parentheses anymore on the right side. And on the left side, I'm left with s over pi r. All right, well, next step is subtract r. So I'm going to subtract r, and I'm going to subtract r. Now, the reason I didn't put it directly underneath is s over pi r is all one term. So even though there's an r in it, these are not like terms again. They're not exactly the same. So they are not going to combine together. All right, well, that cancels these right here. I'm left with L equals, and I'm going to rewrite this in a new order. I'm going to say s over pi r minus r. And there is my steps to solve. L equals s over pi r minus r. You could say negative r plus s over pi r. That all means the same thing. All right, so big things, those to-do-undos can be extremely helpful in this. I'm not going to require them, but you do have to have all these steps to show how you solved it down and got to where you got.